Hey, Mr. Pepperell here, and on this video I'm just going to take you on a quick run through calculations using the principle of moments. So in this picture here I've got a weight on a plank which is balanced by a weight on the other side of the pivot on the plank as well. Okay, now that plank is balanced there, and that's going to be important for the calculation we're going to do. Okay, as far as we're concerned the plank is not moving at present. So the question says a 20 Newton weight, that's this one, is placed on a plank 1 metre from the pivot, so it's 1 metre away from our pivot point there. The plank is balanced by a weight over here which is 2 metres from the opposite side of the pivot. What was the weight? Now, although I've got the weight there in my diagram, we're going to actually calculate and see if that weight comes out to be correct. Okay, so for this question we need to think about the principle of moments, which basically says that the clockwise moment, which is this one here, going in a clockwise direction, has got to be equal to the anti-clockwise moment for the plank to stay balanced. Okay, so clockwise moments have to equal anti-clockwise moments, and that is what we call the principle of moments. Okay, if the plank is not moving, the clockwise must equal the anti-clockwise. So our first job in this calculation is to work out the bit we know, and we know that this weight is 1 metre from the pivot, and we know that the weight is 20 newtons. So my first thing to do is work out the clockwise moment on this side of the plank, and the way I'm going to do that is the clockwise moment is equal to the force downwards in this case, which is 20 newtons, multiplied by the distance, which is 1 metre. So I'm going to do force times distance, which is going to be 20 newtons times 1 metre is going to give me a moment here of 20 newton meters. So I know that my clockwise moment is 20 newton meters. So because I've worked out that my clockwise moment is 20 newton meters, I know, due to the principle of moments, that my anti-clockwise moment must also be 20 newton meters for the plank to stay balanced. So to work out what my downward force, or the weight, here is, okay, I know that the weight has been placed 2 metres from the pivot, so I know that my moment of 20 newton meters is going to be my force multiplied by my distance. So if I want to work out what the force is in newtons there, all I do is divide my moment by my distance. So I'm going to do 20 newton meters divided by my distance tells me that this answer should be 10 newton meters, and if I look up there, lo and behold, it is 10 newton meters. Okay, and obviously you could rearrange that equation to work out the weight or the distance of either side, providing you know both the values on one side of the balanced plank. So that is how we can apply the principle of moments to work out either the weight of a mystery object or its distance from the pivot. Any problems at all, don't hesitate to contact me on Twitter at Mr_Pepperell, and I'll get back to you ASAP. Thanks for stopping by.